Hi everyone, good day. Are you ready for another Math Venture with Teacher Rev? Let's start our statistics learning journey. Okay, let's go back to the problem. We're done already with the things that we're supposed to do. This time, let's go further. Considering the ages 13, 15, and 17, this time, let's consider the mean of the population. Take note that the values are 13, 14, 15, 16, and 17. To get the mean, we add everything. We add all these values, so that means 13 plus 14 plus 15. Since we are adding 5 items, we divide this by 5 to get the mean of the population. Okay, so that would be 13 plus 14 plus 15 plus 16 plus 17. And the answer is 75. Divided by 5, that would be equal to 15. So the mean of the population is 15. Let's take note of that. Okay, then let's go to this. Recall, we were able to do this earlier. And this time, these are the means that we acquired. We listed them. We get the frequency from the table earlier here. The next thing that we have to do is to get the mean. Let's try to find out what is the mean of the means. Okay, so how do we do that? We get the summation of the mean times the frequency over n. Okay, so we multiply first the frequency and the mean. 13.5 times 1, that's 13.5. 14 times 1, that's 14. 14.5 times 2, I can use a little help with this. And the answer is 29. 15 times 2, that's 30. 15.5 times 2, that's 31. 16 times 1, that's 16. 16.5 times 1, that's 16.5. Let's use for uniformity's sake. So we add everything, that's 150. Let's verify whether it's 150, that's 13.5, plus 14, plus 29, plus 30, plus 31, plus 16, plus 16.5. And the answer is exactly 150. If the sum is 150, then the sum of the product of the mean of each sample and the frequency is 150. Divided by how many items do we have? We have 10. So the mean is 15. The mean of the sample means is 15. So, the mean of the population, earlier we solved about the mean of the population. It turned out that our answer is 15. The mean of all the samples, on the other hand, the one that we solved earlier, the mean of all the samples is what? Is 15 as well. So, what can we say about the mean of the sample and the mean of the population? The mean of the sample is the same as the mean of the population in this case. We can say that each of the sample mean is an estimate of the population mean. So we're done doing samples. This time, let's focus on standard deviation. We already know the mean of the population, which is 15. Even the mean of the sample is also 15. Let's not include that. Then, we get the difference. We need to get the standard deviation of the population. So, let's get the difference. That would be 13 minus 15 is negative 2. Let's square that. That's positive 4. 14 minus 15 is negative 1 square, that would be 1. 15 minus 15 is 0 square, that would be 0. 16 minus 15, that would be 1 square, this 1. And 17 minus 15 is positive 2. Again, 17 minus 15 is 2, and that would be, squaring that 2 would be 4. Okay. We add everything here, and the total is 1. 4 plus 1 plus 1 plus 4, that would be 10. It's the square root of 10 over, we have 5 items, so over 5, which is equal to square root of 2, and square root of 2 is about how much? Let's see. Decimal form, that would be approximately 1.41. For uniformity, let's have the standard deviation in 2 decimal places. Okay, so there you go. Next, once we have the standard deviation of the population, let's explore further. I have here the standard deviation of every sample. I computed it already for you. Let's get the mean of all the standard deviations. How do we do that? Let's add all the standard deviation divided by how many? Divided by 10, because we have 10 items to add. So we have 0.71 plus 1.41 plus 2.12 plus 2.83 plus 0.71 plus 1.41 plus 2.12 plus 0.71 plus 1.41 and plus 0.71, and the total is 14.14. Okay, so to get the mean of the standard deviation of the sample, we need to identify the mean of the standard deviation of the sample. We need to get the summation. We have already the sum of the standard deviation of every sample, that's 14.14, divided by how many? Divided by 10, because there are 10 items or 10 samples here. So the answer is 1.414. Or if we're going to approximate it to 1.41, the standard deviation of the population is equal to 1.41, and the mean of the standard deviation of the samples is also equal to 1.41. Exactly. The standard deviation of the population and the mean of the standard deviation of the samples are the same. So the mean of the standard deviation of the samples is an estimate of the standard deviation of the population. So, is it also possible to compute or to create a sampling distribution of sample standard deviation? Because earlier, we have a sampling distribution of the sample mean. This time, we can also apply sampling distribution of sample standard deviation. How are we going to do that? To create the sampling distribution of sample standard deviation, we have to identify the standard deviations. This will always be given in your case, because you're grade 7, no? This will always be given so that it will be easier for you to construct the sampling distribution of the sample standard deviation. And how are we going to do that? Let's identify the standard deviation. The first one is 0.71. How many samples have a standard deviation of 0.71? That would be 1, 2, 3, and 4. So that's 4 out of 10, because there are 10 samples, which is also equal to 2/5. Okay, good. Next, let's go to the next item. I'll use another color, this time red. 1.41. 1.41 appeared. How many samples have a standard deviation of 1.41? 1, 2, and 3. There are 3. So that's 3 out of 10. Next, how many have a standard deviation of 2.12? Okay, that's 1, 2 only. 2 out of 10, or 1/5. And last, there's only one, 2.83, and that would be 1 out of 10. If we're going to add 4 plus 3 plus 2 plus 1, that's 10 out of 10, or equal to 1. This is the sampling distribution of sample standard deviation. What have we learned? We have learned that the mean of all sample means is equal to what? To the population mean. Okay, we learned that earlier. We also learned that the mean of the sample standard deviation is equal to the population standard deviation. So, what did we do earlier? We actually did an estimate. Estimate is the process in which a sample statistic is used to estimate a value of the population. What do we mean by that? The sample, we get a sample statistic. In that case, we have the mean and standard deviation. We estimate the value. We solve for the sample statistic, and we use it to estimate the value of the population parameter. Another thing, a point estimate is a single value computed for the sample size and to estimate the population parameter. When we say a point estimate, it's a single value. An interval estimate is the interval within which we would expect to find the value of the parameter. So that's our discussion for today. I hope you learned something relevant on the different points that we discussed about sampling distribution. This had been a great learning adventure. So, see you next time on another Math Venture with Teacher Rev. Remember, don't stop until you're proud. Learning math takes time. Bye!